This is section 4.1, right triangle trigonometry. Here we have a key concept. We have the trigonometric functions. Now, if we set a triangle up like this over here, where we pick this angle down here in the right triangle, then we have the opposite side across the triangle. We have the adjacent side, which is adjacent to the angle that we picked. We could have picked this one up here, but we didn't. And then this side is always called the hypotenuse, and it's going to be opposite the 90-degree angle. When we have a triangle set up in this fashion, then the 6 trigonometric functions of theta are defined as follows. The sine, which is abbreviated sin, and we still say it's sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's the old SOHCAHTOA, and I'm sure you've heard of that before, especially in geometry. But now cosecant is the reciprocal of sine. So cosecant now is hypotenuse over adjacent, and secant is the reciprocal of cosine. And this one makes perfect sense. Cotangent is the reciprocal of tangent. Now you would think that cosine and cosecant would go together, but that's not true. Sine and cosecant go together. Cosine and secant go together. In my opinion, that's probably backwards, but that's just the way it is. So when you think about sine and the cofunctions or the reciprocal functions, you got to think a little bit backwards. Find the exact values of the 6 trigonometric functions of theta. And here we have a right triangle, and the legs are 7 and 24. And we've picked this angle down here, the bottom angle rather than the top angle. So now 7 is opposite, and the 24 is the adjacent side. Well, we need to know the hypotenuse, so of course, we're going to use the Pythagorean theorem. 7 squared plus 24 squared equals c squared, the hypotenuse. So c squared is equal to, let's go, 49 plus 24 squared. And we get 625, so 625. So c is equal to the square root of that. So we have square root of the answer is 25. So the hypotenuse is 25. Now we can find the sine, cosine, and tangent of the angle that's been picked, and that's, of course, the bottom angle of the right triangle. So opposite, SOHCAHTOA, opposite over hypotenuse, 7 over 25. Cosine, adjacent, SOHCAHTOA, CAH, cosine is adjacent over hypotenuse. That's 24 over 25. And tangent is opposite over adjacent, so 7 over 24. Now, the reciprocal of sine is cosecant. So the cosecant now is 25 over 7. The reciprocal of cosine is secant, and that's now going to be 25 over 24. And then tangent and cotangent are reciprocals of each other. So that's 24 over 7. Now let's do this one where they give you, first of all, we're going to pick that top angle rather than the bottom. So now 25 is the opposite, and 31 is the hypotenuse. Well, now we have to get, let's call this the adjacent side. We'll call that A. So now a squared plus 25 squared equals 31 squared. So a squared equals, we're going to take 31 squared and minus 25 squared. And we get 336. Well, I don't think 336 is a perfect square. So square root of 336. Whoops, I don't need parentheses there. Yeah, that's a decimal value. So is 9 in there? And 30, no. 27, 60, no. I don't think 9's in there. 336 divided by 16. Oh, it's 21. So 4 square root of 21. So 4 square root of 21. So now we need, this is A now is 4 square root of 21. Now our sine is, now remember we're picking this angle up here, so SOHCAHTOA, OH, opposite over hypotenuse, that's 25 over 31. So now we know that cosecant is 31 over 25. We need cosine, which is adjacent over hypotenuse. So we have 4 square root of 21 over 31. And so secant of theta is equal to, kind of we're running out of room here. Let's make a little more room. Is 31 over 4 square root of 21. So that's 31 square root of 21, because we're gonna rationalize on this one. We're going to multiply the top and bottom by square root of 21. So that's going to be 31 square root of 21 over 4 times 21. So, we have 31 square root of 21 over 84. That's kind of a mess, kind of an ugly number. Now we need tangent of theta. And tangent is opposite, SOHCAHTOA, opposite over adjacent. So we have 25 over 4 square root of 21, and that's going to be 25 square root of 21 over, multiply both top and bottom by square root of 21. So 4 times 21 again is 84. So now when we do cotangent of theta, we're going to turn, I'm going to take this one right here and turn that upside down. So 4 square root of 21 over 25. If sine of theta is 1/3, find the exact values of the 5 remaining trigonometric functions for the acute angle theta. So let's draw a right triangle. There's the right angle. And let's say this down here is theta. And we know that sine of theta is 1/3. So we know that the opposite, this is opposite over hypotenuse with SOHCAHTOA, S-O-H. So opposite is 1, hypotenuse is 3. So now we have, we need this adjacent side. So a squared plus 1 squared equals 3 squared, which is 9. So a squared is, 9 minus 1 is 8. So a is square root of 8, which is 2 square root of 2. So this adjacent side is 2 square root of 2. So now we have the sine of this angle that I've picked is opposite over hypotenuse. We already know that one. I know that's the given. Cosine is adjacent over hypotenuse, 2 square root of 2 over 3. And tangent of theta is equal to opposite over adjacent, SOHCAHTOA. So 1 over 2 square root of 2. Let's see, we're going to multiply the top and bottom by square root of 2. So we have square root of 2 over 4, right? Because the square root of 2's make 2. 2 times 2 is 4. So now we have cosecant of theta is the reciprocal of sine. That's going to be 3. Secant of theta is now, that's going to be a mess, huh? 3 over 2 square root of 2. That's equal to 3 square root of 2 over 4. Because the square root of 2's, that's going to make 2. 2 times 2 ends up being 4. So now we have cotangent of theta. That's, what should I turn? I should turn this one upside down. Maybe 4 over square root of 2. It doesn't really matter, I suppose. It's all going to end up being the same answer. Well, this right here, that makes 2. 4 divided by 2 is 2, so 2 square root of 2. Let's look at some special cases. We have a 45, 45, 90 right triangle. And a 45, 45, 90 comes from a square. I know that doesn't look much like a square, but let's pretend it is. We cut that square in half along its diagonal. Well, squares have the same side. So this is a side, that's a side, side, and side. So there's the 4 sides of the square. Now if we cut that in half and we look at this 45, 45, 90 right triangle, then we can say, we can do this. We can say, well, side squared plus side squared equals the hypotenuse squared. So 2 side squared equals hypotenuse squared, because we have two s squareds on the left-hand side. And then we're trying to find the hypotenuse. So we square root both sides, right? So we have square root of 2s squared equals h. There's square rooting both sides. But then we have s times the square root of 2 is equal to h. So this h is the same as s times the square root of 2. Now if we divided everybody by s, and you can do that, that's allowed, this would be 1, 1, and that'd be square root of 2. Because you're dividing all the sides by s. Well now, let's pick one of the 45s, maybe that one down there. Then we know that the sine of 45 degrees is equal to, let's see, that's going to be opposite over hypotenuse. 1 over square root of 2, multiply the top and bottom by square root of 2's, we get square root of 2 over 2. Well, the cosine of 45 degrees is equal to, that's adjacent over hypotenuse, and that's also square root of 2 over 2. And how about the tangent of 45 degrees? Well, if we pick this angle here, opposite over adjacent is 1 over 1, which is 1. Well, now we know the others. We know that cosecant, that's the 45 degrees. That's the reciprocal of sine, which is, I'll pick this one right here. It's just square root of 2 over 1. So secant of 45 degrees is also square root of 2, and then cotangent of 45 degrees is equal to the reciprocal of 1 is just 1. Well, now how about a 30, 60, 90 right triangle? Well, that comes from an equilateral triangle where, but this one's kind of on its side. And on an equilateral triangle, we have side, side, and this whole side right here is S. But then we cut that equilateral triangle in half, and so this one is 1/2 of S. So we got the hypotenuse. We have the side opposite of the 30, but what about the side opposite of the 60? Well, we use a Pythagorean theorem again. So let's square this one. 1/4 side squared. There's squaring it. Plus, let's call this the height. It's probably not height for, that's the same as hypotenuse, but that's okay. That's kind of the height of the triangle. Plus h squared is equal to side squared, or in this case, the hypotenuse squared. So now we have the h for height. Well, let's go. H squared is equal to, when we minus 1/4, that's 3/4 side squared, and then we square root both sides, which is square root of 3 over 2s. There's square root in both sides. So this h, this height now, rather than the hypotenuse, is square root of 3 over 2s. Well, now if we divide by s, we get this side is 1, this side's 1/2, this side's square root of 3 over 2. So what do we want to do? We want to do sine of 30, cosine of 30, tangent of 30. Well, sine of 30 is opposite over hypotenuse, so that's 1/2. So cosine of 30 is adjacent over hypotenuse. That's square root of 3 over 2, and the tangent is 1/2 over square root of 3 over 2. But that's a complex fraction. So let's get rid of the complex fraction by multiplying the top and bottom by 2, and we get 1 over square root of 3, which is square root of 3 over 3. And of course, to get the other 6, our other 3, we'd have to do reciprocal. So cosecant of 30 is 2. Secant of 30 is 2 over square root of 3, which is 2 square root of 3 over 3. And then tangent of 30 degrees is, now we're going to turn this upside down, which just ends up being the square root of 3. Well, what about the same information for 60 degrees? So if you want to pause this and write down that information about 30 degrees, that'd be great. But I'm going to erase it and find the same values for 60 degrees. Here we go. Erasing. You should have paused, wrote that down. Now you're back, and away we go. What about sine of 60 degrees? Well, that's opposite over hypotenuse, which is square root of 3 over 2 over 1. Cosine of 60 degrees is adjacent over hypotenuse. That's 1/2. And then tangent of 60 degrees, that's going to be opposite over adjacent. So square root of 3 over 2 over 1/2, which is just square root of 3 when we multiply the top and bottom by 2. What about cosecant of 60? That's 2 over square root of 3, which is 2 square root of 3 over 3. Secant of 60 is now 2, and tangent of 60 is equal to, now we have the 1/2 over square root of 3 over 2. That's 1 over square root of 3, which is square root of 3 over 3. Trigonometric values of special angles. Well, here we go. That's the chart that we just did. Here's the values for 30. Here's the value for 45. Here's the values for 60. And we got that from a square, cutting a square in half, and an equilateral triangle and cutting that in half. Find the value of x. Round to the nearest tenth if necessary. So we're going to round to the nearest tenth. And we have this 35-degree angle up here. And we have the adjacent side, and we have the hypotenuse. That's cosine. So cosine of 35 degrees is equal to adjacent over hypotenuse. So x is 7 cosine of 35 degrees. So let's take 7 times, and we got to go to mode on our calculator. And the mode of this calculator is set into degrees, and you'll find out later what a radian is. But right now, since we're using degrees, and we're hitting the sine, cosine, or tangent button, our calculator has to be set in degrees, so we're arrow over degrees, press enter, and now we're ready to finish the problem. So 7 times cosine of 35 degrees. We press enter, and we get 5 point, round the nearest tenth, 5.7. How about this one? Well, 41 degrees is that angle down here, so now we have opposite and hypotenuse. That is sine. Sine of 41 degrees is equal to 7 over x. Well, now we can multiply by x, divide by sine of 41. So x is equal to 7 over sine of 41 degrees. So 7 divided by sine of 41. And that's equal to 10.7 rounded. 10.7. Inverse trigonometric functions. Inverse sine is the opposite of, it undoes sine. It's not reciprocal. Reciprocal and undoing something in trig functions is not the same thing. It's much different. So inverse sine, let's see what it says. If theta is an acute angle and the sine of theta is x, then the inverse sine of x is the measure of the angle theta. That is, if sine theta equals x, then inverse sine of x equals theta. Use a trigonometric function to find the measure of theta. Round to the nearest degree if necessary. So now we have the opposite side of the theta that we've chosen down the bottom of the right triangle, and we have the hypotenuse. Well, that's sine. So we have the sine of theta is equal to 12 over 15.7. So now, instead of finding the length of a side, we're trying to find the angle. So here we have 12 divided by 15.7. And that's equal to 0.76433. Keep on going, right? So now we have the sine of some angle is equal to 0.76433. Keep on going. Well, we got to get rid of the sine function on the left-hand side. So it'll say just theta equals something. So let's take the inverse sine of both sides. That's the opposite of taking sine. Now, before we had reciprocal. That's much different than inverse sine. So now these kind of cancel each other out, and so theta is equal to, let's take the inverse sine, and that's the second function of sine, and then we can just do answer. And so we have a 49-degree angle. And we're rounding to the nearest degree, so it's really 50 degrees.